Now we're going to look at applications and problem solving, or word problems. So a process that you can kind of go through when you are doing word problems or solving word problems is to familiarize yourself with the problem, read it carefully, choose a variable to represent the unknown, and make a drawing. A drawing is always very helpful when you're working with word problems. And if a drawing isn't appropriate, then maybe writing out what you need to do in words is sometimes helpful. And I'll show you some examples of doing both of those. You also need to translate a problem into mathematical language, write an equation. So you're going to look for key terms. You're going to have to decide, are you going to add, subtract, multiply, divide, where does your equal sign go, and so on. To solve an equation, find all replacements that make the equation true. Always check the answer in the original problem. You always want to check and make sure that your answer is reasonable and makes sense. So it's always good to revisit what the problem is asking you to find and make sure that you have found the correct answer. And as a final problem solving step, state the answer to the problem clearly. So what that means, if you're looking for miles, make sure your solution has the word miles behind it or has a label to it. Make sure it's very clear as to what your answer is and what it represents. So let's look at our first problem. We have a 60-inch board is cut into two pieces. One piece is 4 times the length of the other. Find the lengths of the pieces. So I'm going to start off by just drawing a picture. And it is a rectangle. And now we are going to cut this into two pieces. I'm going to assume that they're not equal, so I'll just make one much smaller than the other. And now we have to decide on a variable. And you always want your variable to represent the thing that you know absolutely nothing about. It may or may not be what you're being asked to find. But the variable should always represent the unknown, what you don't know anything about. So when we read this problem again, one piece is 4 times the length of the other. So it sounds like we know something about the longer piece, but we know nothing about the shorter piece. So I'm going to have x equals the shorter piece. And the reason why I know it's the shorter piece is if it's 4 times, that means I'm multiplying it, that means that's the bigger piece. So I'm multiplying by the shorter piece to find my answer. So the way we're going to represent that is the shorter piece is going to be x, the longer piece is 4 times the length of the other, so we have 4x. And maybe instead of shorter piece, we don't call it shorter piece, maybe we call it other piece, using the same term that's in the problem. So now I have my picture. The only other thing I know is the 60 inches. So I know that these together is 60 inches. So what's my equation going to be? Well, it's going to be x plus 4x totals 60. Now I can go through the equation solving process. I can simplify because I can combine my like terms. X plus 4x is 5x. And now I can divide both sides by 5. And I'm going to get x equals 12. Well, that means the shorter piece, or your other, is 12 inches. If we reread the problem, it says find the lengths, which implies that we're going to have 2 answers. So 12 inches is only half the answer. The longer side is going to be 4 times 12, which is 48 inches. So there's my 2 answers, 12 inches and 48 inches. Now let's look at these sum problems or consecutive problems. So these two problems are very, very similar. There's one little difference, and we'll address that here in a minute. But we first need to look at the word consecutive. and realize what that means and make sure we understand what that means. If we were to think of an example of 3 consecutive integers, and this is just an example, then that's like 3, 4, 5. So those are consecutive in a row. So we're looking for 3 numbers in a row that total 69. So the way we're going to set this up algebraically is we don't know the first number, so we're going to let that be x. So we can say first integer. Now, if you go back to our example of 3, 4, 5, how do you get from the first integer to the second integer? In other words, how do you get from 3 to 4? Well, you take your first integer and you add 1. And that gives you your second integer. And how do you get to the third integer? Well, you take your first number, you add 1, and then you add another 1. In other words, you're adding 2. So algebraically, this is what the integers look like. X, x plus 1, and x plus 2. Now we can write an equation. We know that the 3 integers, the sum of the 3 integers is 69. Sum means total, so that means we're adding. So our first integer of x, our next integer would be x plus 1, and our third integer would be x plus 2. Totals 69. Now I can simplify, I can combine my like terms. I have x, 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 so I have 3x plus 1, 2, so I have 3 equals 69. And now I can start solving. So I need to isolate my x term. That's going to give me 3x equals 66. Divide both sides by 3. And I'm going to get x equals 22. So make sure you go back and answer the question. It says, what are the numbers? So what are the numbers? Well, the first one is 22, which means the next one's 23, and the one after that must be 24. So there's your 3 answers, and those should total 69, and they do. Now this next problem, we're not going to go through and solve the entire thing. I just want to show you how you would set it up, because it is slightly different, and the reason why it's different is because of the word even. We're still consecutive, but now we're consecutive even integers. So this would be an example of this would be like 4, 6, 8. So the way we set it up, we don't know our first integer, so that'll still be x. Our second integer, how do you get from 4 to 6? Well, that's a plus 2. And how would you get to the integer after that? Well, plus 2, or in other words, plus 4. So if you see consecutive even or consecutive odd, either one, you're going to do x, x plus 2, x plus 4. Now the reason why consecutive odd integers follows the same path is if it was consecutive odd, that would be like 3, 5, 7. It's still going by 2's, even though they're odd. So it just, you're starting at a different number. So if it's even or odd, you add 2 every time. If it's just consecutive, you add 1 every time. Okay, so now we're going to do 2 more. And we're going to do number 12 first. We have a rectangle . There we go. Whose perimeter is 88. The length is 2 feet more than twice the width. So as far as my variable is concerned, I know something about the length, but I know absolutely nothing about the width. So I'm going to let W be my variable. And so the width I don't know. The length is 2 feet more than, which implies I'm adding 2. It's 2 feet more than twice the width. Well, twice the width is a multiplication. So twice the width plus 2 is the length is 2 feet more than twice the width. And so opposite sides are 2W plus 2. Okay. Find the dimensions of the rectangle. Perimeter means to add all the way around. So I need to add 2W plus 2. There's one of my lengths. Then I can throw in a width, throw in the other length, throw in the other width, totals 88. So when I combine my like terms, I have 2, I have 1, I have 2, and I have 1. So 2, 4, I have 6W plus, I've got a 2 and a 2. So plus 4 equals 88. Again, remember that perimeter means all the way around, so you have to make sure you include all 4 sides. Now we can start solving. So I would subtract 4 from both sides. That's going to give me 6W equals 84. Divide by 6, divide by 6. And that's going to give me W equals 14, and this is 14 feet. So now go back and make sure that you reread the problem to make sure that we answered what we needed to answer. So it says find the dimensions of the rectangle. So I only found one so far. I only have one answer. So the width is 14 feet. Well, the length, let's cross this out. We're not going to do that problem anyway. The length equals 2 times the width plus 2. We found the width to be 14, so 2 times 14 plus 2. So 2 times 14 is 28 plus 2, that's 30. So we know that our length is 30 feet. And there's your 2 inches, 14 feet by 30 feet. Now we're going to look at number 14. Carly paid $27.03, including a 6% tax for decorations for a party. What was the cost of the decorations before tax? So I'm going to let X represent my original cost. When you're buying something, you pay the original cost plus you pay the tax on that original cost. So we need to find out what 6% of the original cost is and add that to the original cost. And that's going to total $27.03. So x plus 0.06x, those are like terms. I can combine those into 1.06x. And now I can divide both sides by 1.06, and that's going to get me $25.50. So my original cost was $25.50. 6% of that was added to $25.50 to get $27.03.